Thank you. I will not. You're a good man. I'll mark the roll right now, in fact. Okay, if you're an online student watching this video, just an FYI, we are trying the problem on the right side that says how many grams of whatever from whatever. All right? Yes. I don't actually know. Everyone, whoops, once you get it, check your work. Uh-oh. All right, now, everyone, if I forget to unpause today, none of you are my friends. It was written in like 55,000 font. Okay, so take the starting thing, which is 55 grams of F2. That 2, some of you forget. If this is grams, tell your partner what goes down here. Grams of F2. If the bottom, good. If the bottom is grams, what's on the top? Always 1 mole of the same thing. And if I have this unit here, what unit goes down there? All right, the same thing is mole of F2. So I never balance this. It's a 1, it's a 1, and it's a 2. Fair enough. So in front of F2, I have a 1. Now I'm going to come to the back here, and I'm going to have grams of HF. Because remember, the last thing is the same as the unit of the answer. Then grams is always per what? 1 mole of the same thing. And then what must go here then? Mole of HF, and that is a 2. Now, this would be 19, right? Right here? 20 by fault. Okay. 19 plus 1.
57.8. I guess it could be 0.9 depending on how you round. Okay.
So if you had 57 point something and Odessa had 117, you had 117, right? Or something like that? 15. So you guys just had double the answer. Okay, so you did it double because it was diatomic. Probably you, same? Okay. So we ended up with what value again? 50? All right. Okay. How did that go over there, Vaughn?
I don't think she's decided she wants to get a DM.
We're not talking, huh? Do you want to do another one before we move on? Well, did we do all of them in your homework? The gram to gram ones?
I'm going to say no, but I actually don't know.
All right. What one do we have left? Let's do that. 45. I probably have it somewhere. Oh, it's right there. This thing, right?
Yep.
Okay. So take a minute and balance it. Gotta remember to mark Bella absent. Just kidding, everybody. Yeah, you knew I was just being dumb. Gonna try and save you some time here. Aluminum bromide is 267 grams per mole. Aluminum chloride is 133.5. Whoops, that's here, sorry. Okay, that should save you some time. In case you didn't balance it right, double check that first. 2, 3, 2, 3 is how you balance that one. Ooh, oh, good. Okay, try this. We'll see how it goes. It's not gonna be a problem. We're gonna be fine. Okay, so I unpaused world. Um, 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 there we go. So here we go. Bernie will keep an eye on us, even though he's PO'd, but his hands are warm. Okay, moving on. Do you want me to start at the end or the front?
The beginning.
The beginning. In the beginning, that's sacrilegious. That was sacrilegious. I'm sorry. ALBR3. We okay with that? Okay. Then we must have what down here? Say it loud. Say it proud. Grams of ALBR3, which would mean what do we have here? 1. Grams are always per 1 mole of the same thing. Always, always, always. And I gave you that number because I have a heart. All right, now down here, we would have, don't say 1, be careful. We have this unit, which is mole ALBR3, and that's where we would find this number. Okay, now, this is where the picket fence stops telling me what to do, so that I go to the back. I want to solve for grams AlCl3. All right, then this will always match this, right, Bertie? Yes, we will. All right, so we have grams of AlCl3. Ask Derek Davidson for his Bertie Sanders impression. He's really good at it. 1 mole of the same thing. Derek's actually really good at impressions. And then what's up here? Mole AlCl3. We find that right there. And then this is, yeah, this is funny how this one just works out.
Yeah, I know. It's such a nice number.
All right, so these reduce. This is just half of that. So what do we end up with? 15. Who had 15? Raise your hands. Now you did. David?
I'm looking for.
How'd it go? Oh.
Yeah, sucker.
How did you know it wasn't this class then?
Because I was the first person on the TV. Where was it?
Oh.
Oh, it's over there.
No, like,
Oh, it was up there. He remembers that, but not picket fences.
Well, I mean, that's the only thing I remember.
Bernie would be looking down on you right now.
I like 4 or 5.
That hurts my feelings.
I'm gonna walk today.
Okay, all right, you're good. All right, how do we feel about that? Could we do grams to grams?
Oh, no.
Oh, no, it's over there.
Oh,
Can we do grams to grams?
yes.
All right. Before we move on, would you like to do another one of a gram to gram, or are you ready to roll? Okay, the only 2 people I looked at had a, yeah. Okay, you can do this wherever you want. If you get it and you feel like playing on your phone is the best thing to do right now, that's fine. All right, if I were to take, this is an AP chemistry question just coming up soon. Al2CO3, 3. It decomposes into Al2O3 plus CO2. All right. They have to find out how many grams of CO2 there are. This one's tricky to balance. So I'm going to say you have 50 grams of this stuff. And I want to know the grams of this stuff. You can do this anywhere you want. You can do it on any page, any paper. You can do it on your desk if you want me to get you a marker. Jared, want to do it on my new iPad Pro?
Sure.
Or do you want to play on your phone?
I'm playing Minesweeper.
Minesweeper is pretty good for the mind. Okay, fine.
Go, let's get it. All right, I'm ready.
Okay. You don't have Corona, right?
Probably.
Okay, well, we'll live, maybe.
If I got it from the spider. But then he's been quarantined
That
for-
spider, I used to have like 20 of
I don't know
those.
how long he's been quarantined in there for. Probably years,
Whoops.
decades even.
Okay, here you go, my friend.
Oh gosh.
That's where you select. You can put your palm on it. That's it.
Do I have to select when I want to erase?
Yep.
Oh, does it just erase the whole shape?
Yeah, that's the current setting it's on. So yeah,
That's epic.
kind of like when Dallin beats you. That'll be epic.
It's gonna be epic when I absolutely wipe his face across the track.
That would be a waste of the Accutane money I spent on his face. Gosh dang it. It'll just have track rash the rest of its life. You're going to need to make that a little smaller, my friend. You can just.
Distracted by the thought of throwing your son again and again and again. Why?
That was a joke. It was, I either said that or I had to cry. So I went with saying that.
You gave me an option and I chose easy.
I know, I did. All right, it's my fault. Hey, see this thing right here? Just to save me a lot of digital ink, I'm just going to call this A. Yeah, right, because that's just a lot, all right? So I'm going to say 50 grams of A, which means if I have grams there, I have grams here. And anytime I have grams, it's per 1 mole of the same thing. And remember, A is just representing that, so don't panic. You're like, where did A come from? All right, then if this is mole A, this is mole A. And since A represents this, it really means there's one of them. And then we did find the mass, I guess. Yeah, that was 288 right there. All right. Okay, then coming over here, CO2 is not that bad, so I'll just stick with that. We were solving for grams of CO2, which meant this was grams CO2. And grams are always, always, always married to 1 mole of the same thing. Then up there, we have 3 moles now. CO2. 50 times 3 times 44 divided by 288 most likely was 229. Sorry, 220 or 22.9. Oh, whoa, are you having fun, Jared?
Yeah.
Isn't that like just pleasing how that just, it's like you do nothing, but then there's something.
So much fun.
Yep. Okay. Who that tried it were able to get 22.9. Nice. Nice. You took the easy route. James, you probably got it, right? Okay. Cohen? Okay. You sure you don't? Let me tell people in the digital world in case they don't. I said CO2 was 44 grams per 1 mole. Please remember, digital world, when we do this, we're looking at the periodic table. Carbon has a 12 and a 6, and then O, don't break it, has a 16 and an 8. Okay, settle. But there were 2 of these. I really did. So 32 plus 12 was 44. Okay. All right. I would like to now. Hey, my man Bertie. Yo. Man, imagine how toasty those hands were. Okay. I need to find this thing right here. Okay, Jared. I need that back.
Why?
Because you're clearly having too much fun.
So much fun.
All right. Just kind of lay that along the top.
Whoa. At least I got a basketball.
This magnet idea was genius. I don't know who thought of that, but whatever. Okay. This thing right here looks confusing. I will agree to that. Will you open up the middle of your periodic table? Jared?
Huh? Yes, I'm opening my
This is why I don't give you nice things.
It's right there.
Okay.
I've been looking at it the whole time.
Oh, okay, sorry.
Oh, where'd it go?
Okay, this table is right here. Now, please stick with me.
I'm sticking with you.
This table right here is this large thing right here. I want you to add some things in case they're not there. This says given, which is great. I want you to put start on the left side. I want you to put end on the right side. And then I want you to put this red line, well, a line down the middle. Okay? Put a line down the middle, like between them. Okay. Now, this thing, I call it the map. Are you okay with that, Bernie? Okay, good. I call this thing the map. Now, you don't have to use the map all that often, but when we started picket fences, we started like that, right? Then we went to this, and then we've gone to this, right? All right, to know how big the picket fence is, we use the map. So just kind of pay attention for a second. All the problems we just did, we've started with grams and we ended with grams. So far okay? So far okay? To move this star from this starting side to this ending side, it took 3 steps. Those arrows, those 3 steps represent the 3 vertical lines in your picket fence. Okay, so kind of follow me a second here. When we very first started, I went from a mole of one thing to a mole of another thing. Are you okay with that? So that was 1 step. So our first picket fence was just, it looks like a plus sign, right? We only needed 1 vertical line on our picket fence. Then we went, and most kids didn't like this. Then we went from, oh, okay, Tom. The second thing I taught you was grams to moles. And then the reason you didn't like it is because it also was moles to grams. But either step took 1, 2 steps or 1, 2 steps. So that's why both of those picket fence, regardless of the direction really we went, was just 2. Are we sort of all right with that? Okay, so you can use the map to figure out the size of the periodic table you need, or I keep saying that, picket fence you need, based on what you're going to start with. That's why it says start, and what you're going to end with. So that's why we say end. Now, do me a couple things. Put liter right here, and liter right there.
The picket fences we've been doing is like grams, grams, and 3. And I don't see how you can do it.
Say that one more time.
Like the grams and grams, there's been 3 vertical lines.
Right?
And on this thing, I don't see how you can do it.
It's the arrows. 1, 2, 3 arrows. 1, 2, 3 vertical lines. Or if you want to look at it a different way, do you see that there's 1, 2, 3, 4 boxes? We'd have 1, 2, 3, 4 boxes. So it works either way. And it's I don't know, once this thing all clicks, it works well. In fact, this is crazy. Just 2 days ago, Ainsley Bryce, is she young enough that anyone knows her? She was a cheerleader a few years ago. She sent me a message on Instagram that said, "What's the real name of the picket fence?" So I said, "It's called unit analysis." And then she's like, I knew it. We're starting to use it in our nursing program. So they use it for doses. And they'll just set it up like you need this many milliliters, but this came in ounces, and you just do conversions, and it's the same chart, just different words. Okay, what we're going to do now, the rest of the hour, we're going to use these boxes. Now, you always have to cross this line. So just watch for a minute. I'm going to teach you how to go from moles to liters. Start with moles, end with liters. In order to do that, we're going to have to go 1, 2 steps. So moles to liters would look something like this. Now, we're going to talk about going from moles to liters. Sorry, I just did that one. I love myself sometimes. Yes, we're going to go from grams to liters. So, yep, 1, 2, 3. Now, the last thing we definitely need to talk about is this right here that's not written very clear. But this is kind of nice. This is a number that's always exactly the same. And it's always per 1 mole. So I know you can't read it up there very well. But this ratio right here is 22.4 liters per 1 mole. Now, what this is, and you don't have to have a huge grasp on it, but it's saying if you have a mole of any substance in its gaseous form, it will occupy 22.4 liters. Now, if this was a mole of O2, this would be a liter of O2. These things will always match. So liters inside the picket fence, if you use this step, it's always per 1 mole of the same thing. It's a lot like grams. But this time you don't look it up on the periodic table and add. It's always, always, always 22.4 liters per 1 mole of O2. So let's go ahead and attack one of these problems. Here. Did I skip one? Did I skip D?
Yeah.
Okay. Oh, ooh, sorry, Bernie. Well, where is D? Was that the same? Was that it? That is it on page whatever. Okay, so here we go. Moles to liters. So please look at this map real quick. I'm going to have moles to liters, which would be 2 steps. So that's why I have 2 vertical lines. All right, so we're going to balance this. It's a combustion reaction. 2, 6, 8, 10. This is on page whatever, I think. 11, problem D. I don't know why I didn't cut it, but it is on there. Okay, then let me move Bernie out of the way. What does the problem actually say? If you have what?
50 liters of oxygen, how many moles of C3H8
All right. So 50 liters of O2, I want moles of C8H18. Okay. So I've taught you the process so we won't go astray. What do you always start with? The number in unit I gave you. It's a new one. It's 50 liters of O2. But the process can tell me what goes down here. Liters of O2. And I love liters because it's always the same exact thing. It's this thing. There are 22.4 liters, and that's always per what? 1 mole of the same thing, which is O2. So I know this goes down here. So what's down here? Not 1. 10 moles of O2. If you reduced it already, and you can put a 5, it will fix itself in a second either way. Okay, then that's where I get stuck. So I just need to know I'm solving for moles of C8H18. So I have, or sorry, yeah, sorry. We did that one yesterday. C3H8. So I come up here, I had 2 mole C3H8. Yeah, this will be a small number. 0.4. Bernie looks a lot better on that other screen.
So would that be like 4 liters of oxygen for 50 grams?
Yep.
Oh,
So we go over this in chemistry or AP. The oxygen would be called what we say is the limiting reactant. It runs out before we run out of the rest. So the reaction stops.
so 0.4 is like the leftover?
It's not the leftover, it's just how much of it would have been consumed. Okay. Now, that wasn't that bad if we've learned the process. Now, please, please. Sometimes these problems give you moles and ask for liters. The one we just did gave me liters and asked for moles. Don't. The next one, okay. Is this the next one in your homework, actually? Your homework? CaClO3 that's nowhere. Okay. So C4, I have to have it somewhere. I definitely don't. I'm annoyed at myself right now. All right, well, let me just copy this page. And we'll do another one. Here we go. Whoops. Okay, then all I'm going to do is change this. That's literally the only thing that changes in this problem. This is on page what? 15. And I'll help you balance this one as well because I'm in a hurry. Start with a 2, balance carbons, put the number in front of H, put it 4. Took a second. Now you can reduce that to 1, 2, 1, 2 if you want. And then the problem says what, Amber?
Like how many moles of oxygen will be needed to complete combustion? Is that what you're talking about?
Yep.
Moles per liter?
This part right here. If you have 2.25 liters of methane, this is my given. It asks me how many moles of O2. Is that right? Okay. So,
I didn't even get checked.
whoa, I'm sorry, I'm in your spot. I like this seat, by the way.
I do too. It's really nice.
It's very, it's nice and open. And okay, here we go. I'm going to take my given, which was 2.25 liters of CH4. What unit must come down then? Liters. And that one's nice because that's always 22.4 liters of CH4 per 1 mole of the same thing. Then what unit must come down here? Mole of CH4, and that's a 2. I'm asking you for moles O2, so what must go here? Nice job, way to step in and just go for it. Mole of O2. Anyone else have a 0.2? Yeah, that makes sense, because this is 0.1 times 4 divided by 2. I trust him. Yeah, and I can do that math in my head. Because if you look, this is roughly 1/10. This is really 2. So you take 1/10 and multiply it by 2. Okay, raise your hands if you're okay with that. Like, I don't think you're perfect, but if you're kind of all right with it. Vince, no? Medium? Okay. Odessa, you good? Okay. All right. Over there. Somewhat. O'Riordan, you're good with it, I assume? Amber?
Yep.
Great.